Hey everyone, welcome to my channel. So in this video I'm going to try to solve this problem, try to put some code in, and also at the same time I'm going to follow the general interview steps while trying to solve this problem. So first of all, let's read through this question to get a good understanding. So there are n cars going to the same destination along a one-lane road. The destination is target miles away. So each car I has a constant speed I, and the initial position towards the target along the road. So a car can never pass another car ahead of it, but it can catch up to it and drive bumper to bumper at the same speed. So the destination between the two cars is ignored. They are assumed to have the same position. A car fleet is some non-empty set of the cars driving at the same position and at the same speed. So note that a single car is also a car fleet. If a car catches up with a car fleet right at the destination point, it will still be considered as one car fleet. So how many car fleets are there that will arrive at the destination? So let's see the example. We have target as 12, we have 10, 8, 0, 5, 3 as a start point for each of the car. Speed are 2, 4, 1, 1, 3. So the output is 3. Let's see the explanation. So cars starting at 10 and 8 become a fleet because they meet each other at 12. Okay, so it makes sense because car 1 is 2 miles from the destination, speed is 2, and car 2 is at the position 8, which is 4 miles from the target, and speed is 4, so they're going to spend 1 hour to arrive at the target, so they're going to be arriving at the target at the same time. And similarly, we have the following cars, and we have 3 car fleets at the end. So let's see the constraints first. We have n, which is number of the cars, anywhere between 0 to 10k. So if we have 0 or 1 car, then we don't need to do anything. We can think about that as an edge case, but I think it should also be covered by our general solution as well. So target is anywhere between 0 to 1 million, speed is 0 to 1 million, and position is anywhere between 0 to target, but not at the target. So all the initial positions are different, so we don't need to worry about different cars starting at the same place. Alright, so I think that makes sense in general. The only edge case I can think about currently is if there are 0 cars or 1 car, then we just need to return and without doing any further computation. So let's see how to solve this problem in general. So I think the most important part is this sentence, which is this one. So which is this one. So a car can never pass another car ahead of it, but it can catch up to it and drive bumper to bumper at the same speed. So essentially it's saying, suppose we have a slow car and a faster car. Once the faster car catches up with the slower car, then they're going to go with the same speed, which is the speed of the slower car. So this arrives us at a first solution I can think about, which is so let's say each of the car has a corresponding position. So the condition for a faster car to catch up with a slower car is the slower car is ahead of the faster car, and the faster car can catch up with the slower car before the destination, or at the target, or at the destination. So what we need to do is we just need to sort the car based on the position. So if we are thinking, so essentially we are thinking about the distance, sorting by the distance to the target, to the destination in ascending order. So in our case, we can also sort the car using the position in descending order, which is the same effect as I talked about. So the solution is, first of all, we are going to sort each car by position. So this is going to be descending order. And then for each of the car, we also have the speed. So we could use the distance to the destination divide by the speed. Then we can compute what is the hour, how many hours are there for the car to arrive at the target place or the destination. Okay, so it's something like we are going to sort each car by its position, and also we are going to have, and for each car we will have the time to arrive at target. So for this example, let's say we have 108053. So let's say we are going to sort it. So this is 10, and the second one is 8, and then the third one is 5, and then 3, and then 0. So for car 1, it's going to take 1 hour to arrive at target. Car 2, it is 1 hour as well. So for car 3, it is going to take 12. For car 5, it's going to take 12, and for car 3, it is going to take this is okay. So 5, the speed is 1, so this is going to take 7. And for this one, it is going to take, because it is 9, so it is going to take 3 hours to arrive at the destination. And for this car, starting at 0, it is going to take 12 hours. So essentially, after we sort by the car position, and then we just we just do a linear scan towards from the beginning towards the end of the array. So we see, okay, the first car it takes 1 hour, the second one takes 1 hour. So we can merge the two cars to the same fleet. And the third car, it takes 7 hours, which is longer than 1 hour, so it is going to be a separate fleet. Then we start to form a second fleet, and we say, okay, the fourth car arrives, can potentially arrive at the destination before the third car. Then we merge them into the same fleet. And then we see, okay, 12, it takes 12 hours for the last car to arrive at the destination, which is longer than 3, then it is going to be a separate fleet. So essentially, it is like after we sort, we do a linear scan, and once we see the hours we spend to arrive at the destination is longer than the previous one, then we start a new car fleet. So that's essentially how we solve this problem. The runtime is going to be on log n, so the most time consuming part is the sorting part. Okay, so I think we get the general solution, so let's try to do some coding work for this approach. So as I said, if we we don't have an n, so it will be something like if position dot length is smaller than 2, then we just return position dot length. That's the edge case I talked about. If there are 0 or 1 car, then we don't need to do any computation. And then the next thing we are going to do is we will define a class. Let's say have a private static class. Let's define it as a car, and then it is going to have the position, and also it will have the, let's say, the time. Time is how many hours to spend to arrive at the final destination. So you have a constructor for it. Say this is a position, the time. So this is quite boring code, is equal to time. So that's the definition for the car, and then we are going to have an array for the car. So let's see if we have so this would be cars is equal to new car. This would be position dot length, and we are going to fill in each of the cars. So I is equal to 0, I is smaller than position length plus I. So let's say int time is equal to target minus position I divided by the speed I. And then we have cars I equal to new car. First of all, it is a position I, and then it is time. So after that, we are going to sort the array. So we are going to sort the cars with new comparator. So this would be new comparator. This would be public. I would override public int compare, I think. And then this is car as car1, car as car2. So first of all, we are going to sort by the position. So if the position, so it's going to be descending order. So first of all, it is going to be in descent. Okay, so we are going to sort by the position, because the condition says that each of the position is going to be different. We don't need to think about the condition that two cars starting at the same position. So what we just need to do is we just need to return car1 dot car2 dot position minus car1 dot position. Alright, so after we sort, we do one linear scan from the beginning towards the end to see the number of fleets here. So num fleet starting at 0. So okay, so let's starting at 1. So we need to start from the second car actually, because we want to leave like a 1 offset for our comparison. So if the position, let's say if car I dot speed, if it is larger than cars I minus 1 dot speed, then we are going to plus num fleets, and then finally we will have num fleets to be returned. Alright, so I think we got most of the code. I'll just rely on this platform to help us to do the debugging work. Okay, so line 16, which is okay, so private static class car. So it says compare illegal start of exploration. This is protected, or I'm not sure, or it is compared to. Okay, so I think it should be public. So let's see. Java override new car. Well, there is, I have some, so Java custom sort. Okay, so arrays Java collections dot sort arrays. Okay, so it would be, so this is, oh, okay, so I think I missed yeah, I think I missed no, yes, I did miss something there. Sorry, I think made some mistake about the syntax. Let's try to see another thing. Oh, okay, so this is not speed, this is time. Another typo after we fix it. Okay, so now it's accepted. Let's do a submission for it. Okay, so it is wrong answer. Let's see why it is wrong. So we have 6 and 8 and the 3 and 2. So we have 6, which is 2 hours to the destination, and the well, let's see, so 10 and 6, this is 1.3 hours. This one, it is going to take 2 hours, so we should get so we should be able to output as 1. Well, so we have 8 to 10, which is 2 miles away. It takes 1 hour to arrive at the destination. And this one, oh, okay, so it should be double, actually. Yeah, so it should be double. Yeah, should be after we have, maybe we just need to have like a, yeah, I think it should be double, I think. So this time is going to be double. Let's change it to be, yeah, otherwise it's going to do the floor stuff for the division. Yes, let's run the other task case, which is this one. Yeah, let's answer it. Okay, this one, it works. Okay, let's see this one. Why the output is 2 but we are expecting as 1. Let's see why. So we have 10:02. So this one is going to take 5 hours. This one is going to take 6 hours. This one is going to take, okay, so let's see. So we should after sorting we should have 4, and this should be 6. It's going to take 6 hours, and this one 2, 8. It's going to take 8 divided by 3, this many hours, and then the last one is going to take 5 hours. So output is, well, 10 and 2, 1. So why? This one, it takes 8, okay, 8 miles away. This is, so we should be able to merge the first one, the second one together, but oh, okay, so I think I made a mistake. That is because after the first car and the second car meet with each other, they're going with the same speed. And then after they're going with the same speed, essentially the comparison should be between the first car in the fleet and all the other cars. Okay, so let's see how they do it. Okay, so let's say we have fleet, first car in fleet. So let's say this is going to be 0, and then we have if car.i.time is larger than the first car in fleet, then we are going to have plus non-fleet and first car in fleet as equal to I. Alright, I think this time is going to solve our case here. Alright, let's do another submission here. Okay, so this time is accepted. So I made some mistakes here. So in general, when we do the comparison, we should actually consider the first car in the fleet with the rest of the cars, because the first car can be slow and slow down the cars that comes after it. So that's it for this coding question. In case you have any question regarding the solution or regarding this piece of code, feel free to leave some comments below. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.